Hello, hello, my friends. Welcome to our next algebraic expression lesson. Today we are going to be combining like terms in an algebraic expression, simplifying the expressions so they are much easier to work with. So we are going to look at variables and powers of a term to combine them and then simplify them. Did you want to say hello? You might as
What's
well
going on?
distracting me. So, what do we see here? We see a lot of twins, right? A lot of twins that look alike. And that's kind of how I think of like terms. If we have a set of twins, it's like saying one twin is a T and then another twin is a T. We could say T plus T, or we could just combine them and say, guess what? There are two twins, right? There are two of them. If I have a T and a T, that makes it two T's. And that's what we're going to be doing today. Here's how it'll look like in math. You might see a question like this. It will say simplify 2a plus 3b plus 3a. And that's like saying, all right, we have 2 apples, 3 bananas, and 3 more apples. How could we combine those to simplify and make that expression shorter? You're exactly right. We could instead say, all right, we have 5 apples and we have 3 bananas. And that is exactly what we're doing today. We're taking things that are alike, A and A, the two terms, the two apples, groups of apples, and combining them to make it simpler. So here is the definition. Like terms are terms that contain the same variable. You're kind of like they have the same last name, right? The last part of them is the same. And they also have to be raised to the same exact power. Here's what I mean by that. 7m and 8m are like terms because they both end in m. Now, 7m and 18n are not like terms because one is an m and one is an n. That's like having 7 of these, right? And 18 of these. You can't combine, what could we say? These are newts and monkeys. They're not the same. Okay, you can't combine apples and bananas just like you can't combine M's and N's. So those are not the same. Now, I'm going to clear this and let's talk about powers. 7m squared and 18m. Now we're going to have to say no. Those are not the same because one is raised to the second power and one is not raised at all. It's just m. So those are no longer like terms. Here's another way to think about that exponent part of it. If you have a PS3 and a PS2, there's a big difference, isn't there? And it's the same with terms. If we have a x squared and an x to the fourth power, those are not the same. If we have an m and an m squared, those are not the same. If we have a y to the third and another y to the third, where the only thing that's different is the coefficient, those are the same term. Those are like terms. I didn't mention that here, but another way you can kind of see if they're the same terms is if everything is the same except for the coefficient, except for the number in front. So your first name can be different, but your last name has to be exactly the same. All right, let's practice looking at distinguishing if terms are alike or different or not like terms, okay? So this right off the bat is not like terms. They have the same first name, the same coefficient, but their variables are different. So they're not like terms. You have to have the same variable, the same last name. Now 3h and negative h, those are like terms because they both have the variable h. 5x and 5xy are not the same. One has an x, one has an xy. If you wanted to change this, someone just gave me milk and someone just gave me a sippy cup. So pause for a moment. Do you want to say hi? You're interrupting my lesson. Let me get some milk in the sippy cup first. Okay, say bye. Got the sippy cup with milk. Have fun. Okay, so 5x and 5xy are not the same. If we wanted to make them the same, it would have to be 5xy and 4xy. Okay, let's look at this next one. We've got x squared, y to the third, y to the third power, y cubed, right? X squared, y to the fifth power. Ah, we were so close to being like terms, but this right here gave it away. Y to the fifth is not the same as y cubed, is it? Let's look at this last one. P squared, q cubed, p squared, q cubed. Yes! These are like terms. These are not like terms, and those are not like terms. Why are these like terms? Because they are exactly the same. The variables are the same. The exponents for the variables are the same. So now that we know what a like term and not a like term looks like, let's practice combining them. Okay, so here I have an algebraic expression, and I have separated them by terms. And now as I look at those terms, I'm going to look and see which ones are like terms. So the 5x and the 2x are like terms, aren't they? On number 2, my like terms are the z squared and the z squared, not the 4x, because it's not 4x squared, is it? And on this last one, we have, oh, it looks like just 15 and 5. They are alike. Neither of them have variables, so that makes them like terms. So now what we get to do is we get to combine those like terms. So we have a 5x and a negative 2x. Kind of like a minus 2x, isn't it? We've kind of talked about that negative 2x is really a minus 2x. A minus 2x is really a negative 2x. They're basically the same thing. So if you have 5x's, this is what it would look like. It would look like 5x's, and then we need to take away 2x's. So now we have just 3x's. So it's now 3x. We still have this positive 3y that we couldn't combine with anything else. So that is algebraic expression number 1, combined. Let's look at algebraic expression number 2. The two things that are the exact same that we can combine is a positive 8z squared and a positive 12z squared. So if we combine those, we are going to have 20z squared, and we'll still have this positive 4z by itself. Kind of cool? All right, and this one we have a 15 and a 5. If I combine a 15 and a 5, well, that gives me 20, doesn't it? But I still have that negative 3x right here that couldn't combine with anything else. So now we have 20 minus 3x. How we feeling? Do some more? So actually, let's step back. Why? Why do we care about combining like terms? Well, let's consider this family right here. They go to the McDonald's, and the first kid orders 2 hamburgers and a fry and a drink. Okay? And the mom orders 3 hamburgers and 2 fries and 2 drinks. That's kind of a lot to keep track of, right? Well, let's combine the 2 hamburgers and the 3 hamburgers, and let's combine the fry with the 2 fries, and let's combine all the drinks. Once we have them all combined, well, we're going to have 3 drinks, we're going to have 3 fries, and we're going to have 5 hamburgers. And this is going to be a lot easier as a McDonald's McDonald's worker, to get together than having to remember all those all the terms. We went from 1, 2, 3, 4, 5, 6 terms to just 3 terms. It's a lot more manageable. So that's why we combine terms. I wouldn't want to deal with this expression. This one I'd be like, okay, I could maybe handle it, right? So it takes things that might look overwhelming and scary and simplifies it into things that you're like, oh, yeah, I could deal with that. So word of caution, when we combine like terms, it works for adding and subtracting. We're going to talk about multiplying algebraic expressions in a later lesson. So today we're only going to see adding and subtracting. All right, let's work on this. We've got 5p, -5, and plus 12 for our terms. And what are the like terms? We've got a 5p, so here's 5p, and we need to take a p away. So what are we left with? We're left with 4p plus 12. Okay, let's look at this next one. My like term, oh, look at that, 5n and 3n and 2n. So that's 5n's and 3n's and 2n's. Combine all those n's together because they're all the same variable at the end. And I've got 8, 9, 10. I've got 10n right there. On this one, I have 15n and a -5n. So 15n minus 5n is 10n. And I still have a constant by itself, a +5 or a +5. This last one, it looks like my like terms are my n's. I got an n, and I've got 3 more n's, which gives me 4n minus 2. How'd you do on that? Okay. What about if we put it in a story problem? Real life situations, do we need to do this? You betcha. Baseball caps cost $9 and logo patches cost $4. Shipping is $8 per order. You guys could write this algebraic expression as 9n and 4n and plus 8 gives a cost in dollars of buying caps with logos for n players. That makes sense. So it's $9 per player for the cap, $4 per player for the patches, and then no matter how many players there are, doesn't matter, I just am going to pay $8 for shipping. So how could I simplify that expression? Well, we can combine the cap and the logo, times that by the number of players, and this would be a simpler expression to deal with. Karina states that you can simplify the expression 20x plus 4 minus 2x as 22x plus 4. Is that true or false? What do you think? Did she do it correctly? So I like how she got the 20x and the -2x. That seems good. If we combine a 20x and a -2x, does that give me 22x? No, I think Karina is forgetting that this is a -2x or a -2x, isn't it? So Karina actually should have made it 18x plus 4. Did you catch that? I think that might be my biggest mistake as a 6th grade math teacher, watching students combine like terms, is they tend to just want to add everything together, even though sometimes we have minuses when we combine. So combining means we add and subtract. We just combine positives with the negatives. All right, here's our thinking problem. The 3 sides of a triangle measure 3x. The 3 sides of a triangle, let me slow down. 3 sides of a triangle measure 3x plus 6, 5x, and 6x. Write an expression for the perimeter. Perimeter is the fence, right? It's where we add everything up. Then simplify the expression. So we got to add all these up. So if I just write it, 3x plus 6 plus the 5x side plus the 6x side, I'm left with 3x plus 5x plus 6x, which is 14x? Yeah, 14x plus 6 is the whole perimeter. How do you feel? Can you look at the variables and powers and the exponents now and decide how you can combine those terms and simplify an expression? Let's see. Here's your expression. I want you to simplify 3x plus 4y minus 2x plus 8y plus 7. How could you combine that? Go for it. I forgot to pause and I'm doing it without talking. Okay, let's try this. I combined my x's And that's just going to leave me, I have 3 x's, but then I got to take away 2 x's. So that just leaves me with x, or 1x, right? Now, if I combine my y's, they're both positive, so that will give me a positive 12y. And then my constant without a variable. Did you end up with x plus 12y plus 7? Great job! Whether you did or didn't, you're ready for practice and combining like terms. See you later. Practice hard. Love you all. See you later.